Hi, this is Jim Bergman with the iManifold group. Today I wanted to show you a little bit about performance testing equipment and how quickly that can be done. Performance testing equipment is probably one of the most important elements we do anytime we do a startup, service, commissioning, retro commissioning of a system. So I want to show you that this can be done quickly and accurately and introduce you to some new product that we're including now with the iManifold line. So today what I've got out here is a couple of temperature relative humidity sensors. These are going to get me return air, wet bulb and dry bulb, supply air, wet bulb and dry bulb. I have our new 921N manometer so we can get return static, supply static, and total external static. And then I have the newest addition to our family here, which is the Redfish meter, the IDVM510. And we're going to use that product to get voltage and amperage right into the iManifold report as VeriFied readings. This will cut a tremendous amount of time of fat fingering in readings. I think you're going to find this pretty interesting. So the first thing I want to show you here is one of the mistakes that a lot of people make. They forget that our probes are actually wireless, and it's really very simple to take the probe, put it inside a return air grate, go ahead and close that grill up there instead of having to drill a hole in the return or supply. Then I'm going to go ahead and turn on my supply probe, and what we want to do is we're going to put that up into our supply air register. And actually we're going to put it all the way at the end of the ductwork here. This is the very end of it. And what we're doing here is we're making sure that we're actually sampling from inlet to outlet. So we're going to see the total performance of the air conditioning system. So those two are hooked up and we're ready to go. The next step is to hook up our manometer. So I'm going to go ahead and connect my supply and my return. These are magnetic static pressure tips here. So these just simply attach into the duct with a magnet. They're what they call flush mount tips. So there's just a very small amount that penetrates into the ductwork, and that's all there is to hooking up the manometer. Now I'm going to go back here. I'm going to just check my wireless probes, make sure that all my probes are communicating, and now we're pretty well ready to go. So the next step in this is we're going to need to test power on the system. So I'm going to go ahead and hold the handle in a disconnect so that we can start the system up. And now I got the system started here. We're going to go ahead and get the meter and we'll make some electrical measurements. So I'm going to show you how the system's stabilizing, and just a couple of quick notes here. On the iManifold application, this is a stability indicator. If I touch that indicator, you can see that we're looking for a stable temperature split and stable liquid line temperature. Those will change as it goes on a little bit, and we're waiting for the system to stabilize. So we're going to give it a couple minutes, and then we'll go ahead and do the testing. It's not uncommon to see this kind of stuff happen. When the system first started, the liquid line temperature was stable, the suction line temperature was stable. I had this sort of reading here. Now they went out of stable again, and we have to wait till it restabilizes before we make our readings. You can see very quickly that the pressure is coming to line very fast. Our superheat's not quite down yet where it should be. We're at 20 degrees of superheat. Our target's somewhere around 10 to 12. I can take a look here real quick. Our target is 11 degrees of superheat, 15 degrees of subcooling. So we'll let that thing stabilize. Now the voltmeter here, I'm just going to show you how this works. We're going to go into a measurement screen, and you can see our measurements coming in live. I'll go ahead and collapse those boxes. And our airflow, we'll go ahead and collapse that one just for a minute to get it out of the way. And supply and return air static pressures. All right, so now we're down here at the electrical meter, and we're going to turn the meter on. When we turn the meter on here, you're going to want to make sure the Bluetooth symbol is showing. So you can see right here, I'll turn on the backlight, our Bluetooth symbol is showing right here. This button here, the record button, will turn the Bluetooth on or off. So Bluetooth is on, and then all we do here is just hit connect to multimeter. So you'll see it connecting, and you'll see right away it went to DC volts. Our system's obviously not DC, it's AC, so we press the function key, and as soon as we press the function key, it's going to go to voltage over here. So now we've got that up and running. Now we've got a few minutes before the system completely stabilizes here, so I'm going to go back to the Manifold app again. We're just going to check it here. You can see we're still not stable, so we're going to give that a few more minutes to run, and then when we come back, I'm going to show you how to get the rest of the readings. Okay, so we're back, our system's stable, and we're going to go ahead and show you how to get the electrical measurements in. Just a couple quick notes here. This is again our stability indicator showing that we're stable, and our diagnostic indicator is showing the system's operating normally, so we know there's no problems with the operation. And now we can go ahead and look at our electrical section and look at our performance. Our airflow indicator is not indicating anything because our return air temperature has dropped below 70 degrees. The threshold is 70, so we don't have an airflow calculation. In this case here, what we would do is we would get our total external static pressure, which is a ½ an inch right now. And if we look at the manufacturer's chart, that's about 1227 CFM. So I'm going to go ahead and put that in our measurement section. And we're going to go here to airflow nominal tonnage. Instead of our estimated calculated, we're going to use static pressure. It's going to ask us for a CFM, 1227 CFM. And now we'll go ahead and we'll measure our voltage. So when we designed the application to work with a voltage, one of the things that we wanted to make sure of is that you didn't have to look at your meter while you're making the voltage readings. So again, we have this thing set up for AC voltage. We have it set up on Bluetooth. It's connected to the iManifold app. You can see the reading streaming in here. And so we're going to go ahead and get our voltage readings. The one thing we have to do here is this is a package system. It is 3-phase and it is 480 volt. So you can see now we have all our fields put in. Our power factor in this case is always a typical power factor. If you have a meter that actually measures power factor, you can put that in here. In this case, we don't, so we're going to leave the typical power factor number in. So we're going to go ahead and we're going to measure from L1 to L2. And I assume you just heard the tone come in. So I'm going to go ahead and remove that for a minute, and you'll see that it recorded our first voltage reading. What it's doing is every time that you make a voltage reading, it's waiting for the meter to go back to 0 before we get the next cut. So now I'm going to go 1 to 3. And if you look at the iPad, it's waiting again for the 0. So until I disconnect it, it won't go to the next reading. And now I'm going to go L2 to L3. And I have my 3 voltage readings. Now the next function here is I'm going to take the meter and we're going to switch over and we're going to read current. So I'm going to roll the leads up here, just get them out of the way. And I want you to notice something on the application. As soon as I turn the meter here to milliamps and again push the function key, that the application automatically determined that the meter was set to amps, set it to AC, and it went to the first current measurement. Again, no interaction with the electrical meter required, aside from getting it set up properly. In this case here, I want to use the milliamp connections, so common and milliamp, and because it's so tight in this disconnect box, what I'm going to do is close this up and I'm going to actually measure the incoming power. Now again, I don't have to actually look at the meter, I can just listen for the audio tone. So there's my first current reading. Second current reading. And notice there's a small delay in here. We are waiting for the reading to stabilize. So we're actually running an algorithm in the background to make sure that enough readings have been taken that we get a good stable reading of current. Again, it's waiting for 0. Clip it onto the third lead coming in. And I have now all 3 legs of power. So if I come back over here to my iManifold application, you can see my voltages and my currents. The reason that we have this current imbalance here is because this system has an ECM blower in it, and they're robbing 2 legs for a transformer to power the ECM, so the center leg doesn't see any of that current, and that's what we're seeing. Later in the application, I'll show you how we calculate the current or the voltage imbalance in the application. So the last thing we need in our measurements here, we'll just close electrical, is our static pressure. So right now you can see I'm reading total external static pressure. I'm going to go ahead and capture that reading, and then I'm going to remove over here my supply air static probe. So now I have no probe in the supply, and I'm going to activate my return, which is what I'm actually reading. You need to give this a few seconds to stabilize. We dampen the reading so it's a little bit more stable. Once you see that the reading's stabilized, right now it's stable, we'll go ahead and hit capture, and it's going to then automatically calculate the supply air by subtracting the return from the total external static. So now we have all of our readings in the iManifold application. So I'm going to go ahead and hit submit on the top here, and then go over here to reporting. You can see I already have my customer information already filled out, so this is data that we can pull in from our cloud. So I'm just going to take a test out snapshot, hit OK, go down here to the iManifold report, and we'll just generate that report. And you can see that quickly we have all the information filled out. Pressures, temperatures, air side measurements, static pressures, electrical measurements, supply, return static, all of our system performance, and everything filled out. Now, there is two readings here. You'll notice that we don't have adjusted capacity and adjusted and realized capacity. The reason that those aren't showing up in this case is because our temperature is 68 degrees. We're below the threshold where those things can be calculated by the application, and that's just part of physics. It's not a limitation of our tool, but actually a limitation of physics, that you cannot look at air conditioning performance below about 70 degrees. It just is impossible. But this gives you an idea how quickly we can go through and test the equipment, make sure everything's operating properly, and fill out this performance report, and it literally takes minutes to do. This is Jim Bergman with the iManifold Group. Thanks a lot for watching.